Hi guys, we're going to go over the Magnesium Lab Calculations. So we had our small strips of magnesium, we burned them in oxygen, and we took our final mass of the magnesium oxide in the crucible. What we need to find is the mass of the magnesium oxide that was in the crucible, and then we need to use that to figure out the mass of the oxygen that was consumed when we burned it. All right, so if we had an ending mass of 15.57 grams, and that was the mass of the crucible with the magnesium oxide inside of it, we're going to subtract the mass of the empty crucible, and that will tell us the mass of what was inside. So the empty crucible is going to be 15.11 grams. And when we subtract, we get 0.46 grams of magnesium oxide inside my crucible. Okay, so how much oxygen was consumed? Well, the magnesium, before we burned it, the magnesium little pieces in my crucible had a mass of 0.34. And then after we burned it, it had a mass of 0.46. So from here to here, all the way over there, how much oxygen had to be added? Well, the mass went up, so we need to figure out how much the mass increased by. We're going to do that using subtraction. Okay, so it went up to 0.46. It started at 0.34. So that is a difference of 0.12 grams, and that is how many grams of oxygen attached itself to this magnesium. Okay, so remember that our guiding question at the beginning was, what is the ratio of magnesium to oxygen? So now I know how much magnesium, we had 0.34 grams of magnesium, and I know how many grams of oxygen, and I want the ratio of these two things. But we need to take a closer look as to what we're actually taking the ratio of. I can't compare magnesium atoms and oxygen atoms by mass because they weigh different amounts. So we have our magnesium before, which we said had a mass of 0.34 grams here. We burned it in oxygen, and some oxygen added itself. We ended up with a mass of 0.46 grams at the end. That was our magnesium with oxygen attached to it. So to figure out how much oxygen attached itself, we used subtraction, right? So we had our 0.46 minus 0.34. And when we subtract these little magnesium atoms out of here, we found that we had 0.12 grams of oxygen that was added. Okay, so the ratio of this magnesium to this oxygen, these are the two stars of the show, the magnesium and the oxygen, because that's what's in our product, and we want to know what the ratio of magnesium to oxygen in our product is. We have to first know how many little atoms there are, and I have an analogy for you guys. So let's suppose that we had a jar filled with coins, and we had a certain number of pennies and nickels, and this is kind of like our product here. It's a mixture, right? Actually, this is a compound, not to confuse you guys, because these atoms are bonded together. This is a mixture down here. So they're slightly different, but this is an analogy of something we can see. All right, so if I told you their masses, the mass of the pennies in the jar was 37.5, and the mass of the nickels was 35.0, you might think, well, the ratio of pennies to nickels has to be really close to 1-to-1. Okay, but you can tell by the picture that that's not the case, because pennies only weigh 2.5 grams, but nickels weigh 5. So nickels weigh twice as much as a penny. They're bigger. They're heavier. They have more mass inside of them. So what we really need to do is figure out, well, if I have 37.5 pennies, how many pennies is that? Okay, and we can do that using this equality up here. This is our molar mass. 1 mole equals a certain number of grams. This is our molar mass, just like we have this conversion factor here between pennies, number of pennies, and the mass of those pennies. And we have to figure out how many nickels. So that's some easy division that I did down here. When you divide 37.5 grams of pennies by the mass of each penny, you find out that you have 15 pennies in the jar. And when you take the total mass of nickels, 35, and divide it by 5 grams per nickel, you find out that there were 7 nickels. So the ratio is not even close to 1-to-1. The ratio is 15 to 7 of my coins in this jar. So very similarly, we're going to look at the ratio of our magnesium to our oxygen. And oxygen is smaller, magnesium is bigger. So we're going to find the moles of magnesium and oxygen from the lab. We had 0.34 grams of magnesium in my crucible. And to change that to moles, we are going to divide by the molar mass. So the grams of magnesium go on the bottom. 1 mole of magnesium goes on top. This molar mass is found on the periodic table. For magnesium, the mass is 24.31. So we're going to divide by 24.31 grams per mole. And that gives us a mole of 0.34 divided by 24.31. That gives us 0.01396 moles of magnesium. So we've found how many, the amount of magnesium atoms in there in moles. And let's find out how much oxygen we had. We had 0.12 grams of oxygen over 1. The molar mass of oxygen, if we look at up on the periodic table, is 16.00 grams of oxygen in 1 mole. And upon dividing, we will find that 0.12 divided by 16 gives us 0.0075 moles of oxygen. So what we are looking for, remember the guiding question is what is the ratio of magnesium to oxygen? Now that we know the amount, okay, remember mole is related to how many particles. 1 mole is just Avogadro's number of particles in our crucible. So we don't have quite 1 mole, we have less than a mole, but it's still telling us how many magnesium atoms are in there. So to find the ratio of these two numbers, we're going to divide by the smaller of the two, which happens to be oxygen. So we're going to take oxygen and divide it by itself, and we will of course get 1. And then we're going to take the moles of magnesium, which is 0.013986, and divide that by the moles of oxygen, and we will get 0.013986 divided by 0.0075, 1.86, which for this lab, this is not a very accurate lab. This is going to be close to the number 2. So this is a 1-to-2 ratio. So our final ratio is 1-to-2 for magnesium to oxygen. And what that tells us is the formula of our magnesium oxide that was in the crucible. So the formula of this magnesium oxide here, the ratio is going to be 1-to-2. So my formula would be 1 magnesium, you could just put Mg, and oxygen, if I have 2 of them, that's going to have a subscript 2. Okay, so this and this is my final answer for the lab.